Hey everyone, in this video we will see how we can implement the first in first out page replacement algorithm with the help of a C program. So in the previous video we have already seen what is FIFO page replacement algorithm and how it can be applied on a given question, okay, with the help of example. So if you have not watched the video of the first in first out page replacement algorithm, you can find the link in the video description below in the operating system playlist or here in the I button also. So you must watch that video before understanding the program for this FIFO page replacement algorithm. So on my channel, you can find the full playlist of the operating system and you can find the various topics and you can find the C programs of the various topics. So you can watch that video also. You can find the link of those videos in the operating system playlist in the video description below. Okay, so let's start. So this was one of the example while we discussed first in first out page replacement algorithm. So we are given a reference string, that is the number of pages we are given, okay, and we are given that how many free frames we are allocated to this given process. Here we are allocated 3 free frames, okay, and we have to find the page faults. So we applied the FIFO algorithm and we found there are total 15 page faults, okay, that is 15 times your reference page was not found into the main memory, and 7 times you found the reference page inside the main memory or inside these 3 frames, okay. So these are the page hits, okay, the number of times your page is found inside the main memory or in these frames, okay. So just to recall how we applied the FIFO algorithm, we saw first you take this page, okay, this is the first page, you put into the free frame, okay, because we have total 3 free frames, okay. So we can just find the empty space and we can put it into the first location. So this is the 0th location, first and second, okay. After that we got 0, okay, again 0 is not present inside any of the frames, okay, so we got page fault and then we put it into any one of the free frame, so we put it here, okay. Then we saw, okay, one is not present here, so 1 will generate page fault, okay, and then we put 1 here, okay, so we got 701. After that when we encounter 2, okay, all the frames were allocated to 701, okay, so that means this 2 will not be able to find any free frames, okay, so we have to replace any one of the existing page from these frames, right? So we have to apply the FIFO page replacement algorithm as we are applying here FIFO, right? So FIFO will say, okay, which is the oldest page that came inside the main memory, or which is the page that came first inside the main memory, or you can say inside the frame. So you say out of 701, 7 is the page, right? So you replace 7 and you put 2 here, okay. So my new content was 201, okay. After that when you encounter 0, you said, okay, 0 is already present, so it is like a page hit, okay. When you encounter 3, so you said, okay, you have to replace any one of the page because 201, they have occupied all the 3 frames, okay. So which page should be replaced by 3? So you saw 7 was the first page that was replaced. Now 0 will be the next page that will be replaced according to FIFO, okay, because this is the next page which came after 7, right? So 0 will be replaced by 3 and my new content will be 231, okay. So after that 0 again came, but out of 231, 0 is not present, okay, so 0 will generate page fault. Now again which page should be replaced? So we will say, okay, this 1 will be replaced, okay, because 7 is replaced, 0 is also replaced, 1 is the next page that will be replaced, okay. And we saw, okay, then 0 came, okay, 0 will not generate page fault. When 4 came, again you saw we moved into a circular fashion, right? We saw that 4 will replace this 2, okay. So we first replaced 7, then 0, then 1, okay. Then again we replaced from here, that is the from the frame number 0 we replaced this 2. Then we will replace 3, then we will replace 0 whenever there is a need. See, if we replace 3, then we replace 0, right? Again, if there is a need, we will move into the circular fashion. See, 4, then 2, okay, then 3 is going to be replaced. So this is one of the specialty of, you can say, the FIFO algorithm, that you replace the page in the circular manner, right? And this property we will use while we will implement this algorithm in our C program, okay? We'll move again and again into the circular fashion, right? Okay, so this was just a recall for the first in first out page replacement algorithm. to get to know more about this FIFO algorithm, okay, you can watch the video of the FIFO algorithm. Okay. Now before moving forward, let me tell you, I will take only this much part of my reference string to understand my program, okay, because it will be easy to take a shorter reference string. Okay. And so let me tell you that how the program of this FIFO algorithm will give me the output window. Okay, that means how my output will look like, because that will give you a better representation of your goal, that what you want to achieve by implementing this FIFO algorithm. Okay, so let's see. Now before going forward, let me tell you, I will take only this much part of the reference string, okay, for our rest of the program, okay, so that we can understand our program from this shorter string. Okay. And now let me show you the demo of the output window that will be shown by this C program for this first in first out algorithm. Okay. So that output will give you a better representation that how my program will look like actually. Okay. So let's see the output window for this C program. So this is the output window of my C program for the first in first out page replacement algorithm. Okay. So my output will first ask me that please enter the total number of pages. Okay. So I'll enter 12, let's say. Now it is asking me to enter those 12 pages, okay, that will constitute the reference string. So the 12 pages are like 701. Okay, I'll enter the rest of the pages. So this is my reference string. Now I will enter how many frames I want to allocate. So let's say I said 3. Okay, so you see the total number of page faults are 10 that are generated by this reference string. Okay, when the CPU accesses these pages. Okay, and the page fault ratio is 0.83, and the page hit ratio that we want to print is 0.17. Okay, so I'll tell you what is page fault and page hit ratio. Okay, and these are the different you can say content present inside 3 frames, okay, at different point of time. So initially only 7 came, then 70 came. Okay, so you can see the last entry is like -1. So actually initially I have put all the you can say pages inside all the 3 frames as -1. Okay, so -1 is an invalid page number. Okay, so I have said okay, every frame contain initially -1. Okay, now after that 1 will came, then my content will be 701. Okay, then my content will change accordingly when 2 will come. Okay, so it will replace 7, so it will be like 201 and so on. Okay, so lastly when all the pages are like exhausted, my final content will be 023 inside the 3 frames. Okay, and these are my page faults and the page fault ratio and page hit ratio. Okay, so let's understand how I can generate this output, or you can say number of page faults from my given input. Okay, so this you can say this content which are shown at different point of time, you can just print or you can just skip. Okay, this is just for your better readability. Okay, the main thing is we have to print the page faults, and then we have to print the page fault ratio and page hit ratio. Okay, so now let's understand the different sections of this code step by step. Okay, so as you saw in our program, the input will be first I will enter the number of pages that I want to enter in my reference string. Okay, that will be denoted by, let's say, n. Okay, I entered 12. Then what I will enter next, I will enter the pages, okay, that are referenced by the CPU. Okay, and to store those different pages, or the you can say there can be same pages also in the reference string, I will use a array. Okay, the array name is reference string. Okay, and that will be of size 12 because I want to accommodate 12 pages. Okay, so this is a like array. Then I will enter total number of frames that I want to allocate. Okay, so those number of frames, they will be denoted by number of frames variable, okay, in my program. So let's say I entered 3. Okay, so what I will do to accommodate those 3, you can say the different pages in the 3 frames, I will create a array of size 3, and the name of the array is frame. Okay, so this will be frame 0, frame 1 and frame 2. This is the array to store the different pages at various point of time. Okay, frame array. And the output will be total number of page faults, page fault or miss ratio, and page hit ratio. Okay, so in our given question we saw that page faults were generated were 12. Okay, so what is page you can say fault ratio? So in our given question, the total number of page faults generated were 10. Okay, so what is page fault or page miss ratio? So page fault ratio or page miss ratio is like total number of page faults generated, that is 10. and divided by total number of pages in your reference string. Those were 12. Okay, so out of 12, 10 times page faults were generated. So this will be your page fault ratio. Okay, you can find it. It will be nearly 0.83. And page hit ratio is the total number of page hits divided by the total length of the reference string. Okay, so in our reference string from 7 to like last 12 pages, the 10 times there was page fault. So how many times there will be page hits? It will be 10. It will be 3 times, right? So 12 minus 10, this will be the page hits or number of page hits divided by n, that is 12. So it will be 2 upon 12, that is 2 1 2, 2 6 12. So it will be 1.6 and it will be something 0 point something. Okay, so this is the page hit ratio. Okay, number of times your page was found out of the reference number of pages. Okay, so yeah, I hope you have understood that what will be the input and the output. Okay, so in between the input and output, I have to apply the FIFO algorithm so that I can get to the output by consuming my input. Okay, so let's see the main part, that is how we can apply the FIFO algorithm. Okay, so before that, let me show you the code. Okay, the small part of the code, that how the code of this input will look like. Okay, so this is my complete code of the implementation of the FIFO algorithm. Okay, using C program. So there are many things, okay, that we'll see later. Okay, let's me start from the main function. So here I have taken the various number of things like number of frames and the counter, which will store the total number of page faults. Okay, so total page faults will be stored inside this page fault variable. Okay, and here you can see we have the total number of pages. Okay, and then I have created that string, or you can say the array of size n, okay, to store the pages. Then I ask the total those n pages, okay, and I store inside the reference string. Okay, so after creating this reference string, okay, and after taking the input, I ask how many frames you want to allocate to this process. Okay, and then I created that much size of the frame. Okay, so for the total number of frames as 3, I created a 3 size frame array. Okay, then initially I have stored everything. Okay, or you can say I have stored all the pages inside these frame array as -1. Okay, using the mem set. You can use the for loop also to store all the pages inside that frame array as -1. Okay, so this was our input. Okay, and at last you can see I have implemented many things, okay, inside this for loop. Okay, and here you can see at last I have printed the total number of page faults, page fault ratio, page hit ratio. Okay, so this is the overview. Okay, so if you see, after taking the input, I have taken something like page table and all. Okay, I'll tell you later. And from here, actually, okay, this is the FIFO algorithm actually. Okay, this is the main part of the FIFO algorithm that we have to understand. Okay, so let's understand it step by step. So now actually I will use only this much part of the reference string. Okay, I think the like the complete string will be like a longer one. Okay, so again I reduced my string, and now I will explain my further explanation using this much part. Okay, these 10 pages. Okay, from 7 to like this 3 only. Okay, so these are 12 10 pages. Okay, 10 pages, and out of 10 you can see one time you found the page. Okay, so total 9 times, okay, you found the page fault. So page fault in this reference string till here it will be 9, and page hits will be 1. Okay, so let's understand with the help of this much part of the reference string. Okay, so as we saw in the FIFO algorithm, when we are putting the pages inside the free frames, okay, in this frame array, we got one property. What was that property? The property was we were replacing the pages in the circular manner. Okay, so let's say these are the frame number 0 1 2. This is the frame array. So I put 7 because 7 can be like put inside any of the free frame. Okay, I put 7 and it generated page fault. 0, again I can put here. 1, again free frame is available, so I can put here. Okay, so till the point free frames were available, I can directly put. But when 2 came, what I did, I replaced this page. Okay, this page. Then 0 came, because 0 is already present, so I need not do anything. When 3 came, I said okay, 0 should be replaced, right? When 0 again came, because 0 is not present, so I said now it should be removed, right? It should be replaced. Okay, so I replace first this, then this location, right? Now again I will move here, okay, and I will say, okay, this is done, right? This is done, this is done. Now 4 will come. Now there is no space for 4, so I'll say please replace, you can say remove any one of the page. So which page out of 230 I should replace? According to FIFO, this 2 will be the oldest one, so 2 will be replaced by 4. Now 2 will replace this 3. Now 3 will replace next, that is this. Let's say if there are some other pages, like let's say it has 0 also, then again I'll move in the circular manner and I'll replace this, right? Okay, so that means the property of circular movement is present inside our FIFO page replacement algorithm, and this property we will use while we will code. Okay, we need not to actually search for the like which page I should replace, okay, in the whole you can say frame array. I can just move in the circular manner, okay, 0 1 2, then 0 1 2, 0 1 2, okay. This way I will keep on moving to replace the pages whenever there is a need. Okay, so this is one of the property that I'll use. Okay, now next thing is how to keep track that which page is actually present in main memory or not. Okay, so when we are saying that we are coming with 7, okay, CPU want to access 7, so how we will come to know whether 7 is present inside this frame array or not, or whether 0 is present already in the frame array or not. Okay, so one approach is like if you do not so one approach is like if you like do not want to involve many of the complexity, you can just scan this complete array, or you can say complete this frame array, and you can do just linear search, and you can just easily find whether your particular page that you are asking is present inside this array or not. Okay, so this is one of the way that you can apply to implement this FIFO algorithm. Okay, but I'll tell you the another way. The another way it will be, as you have understood in the paging technique, that the page table actually tells you that which page is present inside the main memory or not. So I'll use the concept of the page table. So page table will actually be like a mapping table. Okay, so you know that there is a hash map, there is a map, you can say, okay, hash map is in Java and map is in your C++, okay, in STL library. So you can say simply I will use a mapping table. Okay, this page table, this will help me to know whether a particular page is present in any of the frame of the main memory or not. Okay, why I will tell you this page table in this FIFO, although you can make a simple program without using page table, because this concept of page table or mapping table, it will be used later in our implementation of the least recently used program also. And we will see, after understanding the FIFO algorithm, only a slight change, or you can say 2% change, will be needed in the FIFO code, and we will get our LRU page replacement algorithm. Okay, so our program will be like a, you can say, reusable code. It will become a reusable code for the implementation of the LRU. Okay, so I'll tell you with the help of page table. Okay, the page table, as you know, it is a mapping table. It maps a particular page to the particular frame. It tells whether a particular page is inside any of the frame or not. If it is present, then it tells that particular frame number, right? That we have already discussed, okay, in the previous video. Now the next question is how we will get to know that whether a particular page is present in one of the frame or not. So actually the frame number is like the actual frame number where my entry or my page number is stored. Let's say page number 2 is present here. Okay, page number 2 is present here, so it will tell me page number 2 is present in frame number 1. Okay, but let's say I come for the, you can say, 7th page. Okay, so 7th page is here. Okay, but there is nothing. Okay, so there should be some technique by which your CPU can get to know, okay, there is nothing. Okay, and there is no frame inside which 7 is stored. Okay, so what is that thing that will be able to tell you whether a particular page is present in any of the frame or not? Okay, so that thing is, as you know, valid bit. Valid or invalid bit, it will tell you that whether a particular page is present inside any of the frame or not. Okay, and the actual frame number will be given by this frame number column, right? So initially everything will be like false, okay, or you can say invalid. Okay, that means initially your frame should be empty. So 7 will not be present in any of the frame. Same way, no page, okay, no page will be present in any of the frame. Okay, so yeah, this is the work of the valid and invalid bit. So we will use this page table which will contain frame number and the valid and invalid bit. Okay, so this is a mapping table. Okay, you need not to apply the linear search to find whether a particular page, okay, whether a particular page from this reference string is present inside any of the frame or not. Okay, you can just go to the this mapping table. Okay, let's say you want to search for the 1 and you want to say 1 is present inside any of the frame here or not. So you will just go, okay, 1, okay, valid bit is actually 0. That means this is like a invalid. So that means whenever this is 0, it means the particular page is not present inside any of the frame. Okay, so yeah, you just simply go to that particular page and you got to know, okay, in constant time, or you can say in O of 1 time, you will get to know. Okay, if you apply the linear search, then it will take like O of number of frames times. Okay, this much of time to get to know whether a particular page inside any of the frame or not. Okay, so let's see how we can like code this page table or this mapping table inside our C program. So here you can see in our code, I have taken a structure. Okay, so my structure name is struct page table. Okay, and it will contain the frame number and the valid invalid bit. Okay, so frame number is like an integer number, valid invalid bit will be like 0 or 1, or you can say true or false. So that's why I have taken a bool type variable. Okay, bool valid. You can take int, but to reduce the memory space, I am taking bool type variable. Okay, now this page table, okay, this page table, or you can say this structure is just a template. Okay, so what will be the size of this page table? Okay, so if you go down, you will see inside the main function. Okay, I have taken this pt variable, and this is an array of structure. Okay, the pt is the name of the array, size is 50. So basically I have taken a constant size of this you can say page table. Okay, I have taken the that I can store total entries of the 50 pages, okay, from 0 to 49. Okay, you can take any other number also, like 100 size page table. Okay, that is up to you, or you can take like from the reference string. Okay, let's say the maximum page that is referenced as 15, so you can take like the page table size as something like 15 only. Okay, so it is up to you how you declare the how you declare the size of the pt array. Okay, but let's say I take a big size page table. Okay, 50. So initially I have put everything inside this page table for the valid bit as 0, that is it is false. Okay, okay, so this is the initialization of the page table. Okay, so this is simply a you can say mapping table which will store the frame number and the valid and invalid bit. Okay, so after that my main code starts. Okay, here you can see the content side, the frame array different time, and then this is the main code. Okay, so we have to understand this for loop. Okay, so this for loop is actually what it is doing. It is from the reference string, it is taking each and every page number, and it is checking whether that page is inside the frame array or not. If not, then generate page fault. Okay, and then do something something something, okay, repeatedly, okay, for all the reference string page number. Okay, and after that just print this. Okay, so our motive is now let's understand this for loop, then how this for loop will actually work. Okay, so let's see. So basically this for loop is actually scanning this whole reference string. Okay, from 0 1 2, okay, this will be total 3 4 5 6 7 8 9. Okay, so from 0 to you can say, and value will be 10. Okay, from 0 to 9 we are scanning this reference string and we are fetching each and every page one by one, and we are doing these things. Okay, so what we are doing, this is actually like a page table, and this is like a your frame array. Okay, or you can say this is the main memory. So for every page we are coming, okay, for every is page we are coming and we are searching first. Okay, with the help of page table we are getting to know whether that ith page, okay, is present inside frame array or not. Okay, so we are actually not going to the frame array to search, we are going just to the page table. Okay, we'll see in the code that this will use page table, okay, for searching. So let's say 7 will come. Okay, I'll go to this 7. Okay, and here everything initially will be 0. Okay, so initially this 7 will come and I'll check valid and invalid bit. Okay, this is valid invalid bit and this is the frame number. So for 7 this is 0, that means page is not present inside any of the frame. Okay. So if it returns false, or you can say let's say if this thing say okay, page is not present. So if page is not present, we'll come here and we'll simply say page fault, okay, generated. So I'll increment the page fault, which was initially 0. Okay, so initially it was 0, now it will become 1. And after that we have two options. Okay, what are the two options? Now I have to place this 7 in one of the frame, right? Okay, so what should I do? I should find the free space inside the frame array. If it is available, then I can put 7 inside that free frame. But let's say if all the frames are occupied, let's say by X, Y, Z, these are the page numbers which are occupying these frames, then I have to find the free frame. Okay, that means I have to apply the FIFO and I have to vacant when any one of the frame. Okay, and then I could put this ith page inside one of the you can say empty frame. Okay, so basically this if and else are doing that thing. So if is basically saying if my frame array has backend frame, okay, then you can simply do this thing. If my frame array is full, then you do this thing. That means first apply the FIFO and then create a space. Okay, then put that ith page inside your frame array. Okay. This way I'll go to the then next page, and for the next ith page I'll do the same thing. Search inside the page table. With the help of page table, I got to know if it is not present. Okay, just come here, increase the page fault, then see if array has space, then put that ith page inside the here. If not, if frame array is full, then apply the FIFO algorithm. Okay, make the space and then put that ith page, okay, here, right? And this will go on. Okay, let's say if a particular page is already present. Okay, let's say we have 7, we have 0, 1. Okay, and then after some time 2 came, 2 will replace here, as we saw. When 0 will come, okay, when 0 will come, okay, 0 will come, 0 is already present. Okay, so if will be false, so will come simply. Okay, will not do anything. If our already page is present inside the frame, will not do anything, will not increase the page fault. Okay, we will simply go to the next ith page, that is 3. Okay, so this is the overview. Okay, now here one thing you have to understand is, let's say we come for the ith page, let's say for 7. Okay, and 7 is not present, we generated the page fault. Okay, and the initially all the frames will be free. Okay, so frame array will have vacant frame. So when we are putting that ith page into the vacant frame here, let's say, then we are updating the page table also. Why? Because 7 has come in the main memory. Okay, so for the 7 we'll say the page number, sorry, the frame number is 0 in which you are placed. Okay, so we are updating the page table. Okay, this is important, we'll see. Okay, and the valid bit will also be set as 1. Okay, so if next time let's say here 7 comes, okay, so we'll come to this page table and it will tell me, okay, this is 1, that means particular page is present inside the main memory, and in which frame? 0th frame. Okay, so that's why I have to update the page table also after I enter any of the ith page inside the frame array. Okay, the same thing if I frame array is full, let's say here it is 0, it is 1, let's say, and next time if let's say 2 came now, so what I have to do, I will do all these things. Okay, then I will not come here, right? See, for here I can come only when frame array has vacant frame, and frame array will have vacant frame only for these 7, 0, 1 only. After this, for these pages, frame array will not be free, it will be like full. Okay, so for 2, 0, 3 my else will run, and for initial 3 pages my 7, 0, 1 will run. Okay, or you can say for initial pages my if code will run. Okay, and for the all pages my else code will run. Okay, so when I will come here, I have to just like first find the free frame using the FIFO. Okay, but when I put the ith page inside frame array, let's say I put 2 here, then again I have to update the page table. Okay, for 2 I will say you are in 0th frame, right, and you are valid. Okay, and before putting this 2 here, I have to say, okay, 7 you are now going. So for 7 I'll set it to 0. This I have to do here. That means here first I have to update the page table for 7. Okay, update page table. Then I'll put 2 in 0 frame. Okay, I'll put, and after that again I will update the page table. You can say update page table for 2. Okay, so here 2 times page table will be updation will be done, and here only 1 time. Okay, so let's see how we can apply this using our this reference string one by one. Okay, so here you can see this is my for loop, right? This is my for loop, and inside this is if, then this is the page fault plus plus, this is the if code. Okay, and next this is the else code. Okay, then my for loop will end here. Okay, so my if code, this code will run for first of the 3 pages. Okay, and after that my else code will always run. Okay, so let's understand this if. Okay, so here you can see let's come to this reference string. Okay, so for I equal to 0, I will come to this. Okay, this is the 0th one. Okay, so I'll say okay, whether this is 7 is present inside this you can say frame. Okay, with the help of page table I will get to know. So I will go to this 7 and I will see whether it is present or not. So initially everything was 0, right? So I'll come here and I will come, okay, is page present? Is page is present inside my frame array? Okay, so I'm passing the, so I'm creating a page present function. It is taking the page table, the reference string that I want to search, that is 7, and the, you can say this n. Okay, basically I actually do not need n. Okay, I can just remove it. Okay, so my page table is passed and the reference string 7 that I want to search. Okay, so this should return false. Okay, because my 7 is not present. So if you go up here, if you go up, each page present is a function which returns either true or false, bool type value. Okay, so it will come and it will say okay, it will check just valid and invalid bit. Okay, so it's page table, page number is 7. Okay, that is coming here. Okay, so this is not needed. So page table, then 7. Okay, dot valid, this is equal to 0 actually, right? So if it is 1, then only I will return true, otherwise I will return false. Okay, so for this 7, this is not true, so I'll return false. Okay, that means this 7 is not present inside the page table. Okay, there is no mapping of this 7 to any of the frame, so I will come with the false. Okay, now the main thing is you have to go inside. Okay, although 7 is not present, but you have to go inside, so I will just use this not operator. Okay, and I'll become, this condition will become true and I will come inside. Okay, so page fault will be incremented, so page fault will become how much? Page fault will become 1. Initially it was 0 actually. Okay, and now I have to come here. Okay, this will run. So I have taken a variable called current. Okay, so current variable is initially 0. Okay, and number of frames are actually 3, right? So what will happen? My current variable, which is initially 0 and number of frames are like 3, so it will run from 0 less than 3, 1 less than 3, 2 less than 3. Okay, and then after, at last, this will become 2 now. This will become 2. Here you can see inside the if, here I am saying current equal to current plus 1. Okay, so I am always incrementing current inside this if, right? And after that it will become 3, but 3 is not a valid frame number. Okay, current will become 0, current will become 1, current will become 2. Okay, current after 2 it should become 0, then 1, 2, then again it will come 0, 1, 2. So this current is the same variable that I will use for the circular movement actually. Okay, so let's see how it will be used. So current is actually less than 3, so current is basically used here and pointing here. So 0 is less than 3, yes, so I'll come here, and what I will do, because 7 was not present, so I'll put 7 here inside the frame. Okay, so I will say okay, this reference string I, that means this 0th page, put inside the frame of current, that is frame of 0. Okay, then what I will do, so initially everything was like -1, so my content is 7 -1 -1. So this print frame content is just printing this frame array. Okay, so you can say this is just a, you can say for loop. Okay, it is printing the frame array. Okay, number of frames times. Okay, so yeah, this is the simple code. Okay, so this print frame content is just like a if you want to print. Okay, let's say if you do not want to print, you can just like comment this. Okay, so after putting this 7 inside the frame, what I will do, I have to update the page table. So I'm updating the page table. So the main thing is inside the page table method, okay, update page table method, upt I'm writing, I am passing the page table. Okay, then reference string I, that means this 7. Okay, then what I have to do, because inside the page table I have to make changes here and make changes here. Okay, so I have to pass this frame number also. Okay, this frame number that I have to place here. Okay, so current is storing this frame number, that is 0. So I am passing this 0 frame number, and then I am passing this 1 also. Okay, so 1 is actually like you can say valid and invalid bit, right? So 1 is telling me make it is valid. Okay, this is the valid bit. Okay, so I'm passing 1 explicitly. Okay, so update page table will take all these things. Okay, you can see up. Okay, update page table. So here is my update page table. So page table, then page number will take this 7, frame number will take this 0, and the last will be your valid invalid bit, status bit, it is 1. Okay, so here I'm saying, okay, page table valid equal to status. Okay, that means here it will be 1. And the next thing is update the frame number by this frame number that we have been passed, that is 0. So here it will be like, you can say 0. Okay, so yeah, my both the entries are now done, right? Now, okay, so my 7 was not found, I put 7 here, and then I updated the page table, and then we are done with. Okay, so let's move forward. And what will be the next thing? I will go to the next page. Okay, so here you can see after doing update page table, I am just incrementing the current plus plus. So now current will become 1, so that next time I will put any of the page in this 1th location. Okay, and I will tell you this later. Okay, this thing will be used after the current will come at the last point. Okay, so now again I will move to this for loop I plus plus, that is I come to this 0 page. I'll search this 0 is present inside the page table, again with the help of the same code. Okay, so 0 will come here, with the help of valid I will get to know no, it is not present. So I'll come here, and then I will say, okay, current is 1 now. Okay, it is like checking, current is checking whether I am like crossing the number of frames or not. So 1 is less than 3. Okay, so it is not crossing, so it come inside. I'll put this 0, okay, reference string 0 inside the current frame. So I'll put here, right? And after that, what I will do, I will just print the content. Okay, I'll update the page table, right? So I'll put this 0 here, right? And then I'll update the page table. So inside the page table, what will be passed? So now I will pass pt. Okay, then reference string is my 0, the frame number is like 1. Okay, 1, that means current, and the status bit will be set to 1. Okay, so this string will be passed. So for the page number 0, okay, here I will set 1, and here the frame number will be 1. Okay, so this update page table will do the same thing. Okay, valid and the frame number will be set, and then current is incremented. Now current is incremented to 2, so that next time here my content should be placed, page number should be placed. Okay, so next time again with the help of same thing, this 1, okay, this 1 will not be found. Okay, with the help of this is page present, I'll increment the page fault. Page fault will actually become 3. Okay, here it was 2, here it was 3. So current is 2, 2 less than 3. Yes, come inside, put and update the page table. So 2 will be placed, update the page table, that is here, update the page table. Okay, sorry, this is 1. Okay, sorry, this is 1. Okay, so 1 is put inside this. Okay, and now after putting this 1, okay, after putting this 1 actually here, okay, this is like 1. Okay, after putting this 1 here and updating the page table, current is incremented to, you can say current equal to current plus 1, right? Now current will become 3. Okay, although 3 is not a valid frame. Okay, now here after every time I'm checking current if it is equal to number of frame. So now it is 3, current is 3, and it is equal to number of frame. So I'm saying, okay, if current will become 3, then you just reset it to 0. Then you reset it to 0, and then after which you will say flag equal to true. So flag is a variable which was initially false. Okay, and now it is made true. So here you can see inside main it was false. Okay, so now only it will be made true. And why I am using this flag? So flag is basically helping me ki, okay, next time you should not come inside this if block. You should not come inside this if block. Okay, because after this you should go to the else. See how. Next time if you go for I equal to 3, I will search 2. Okay, this search 2. 2 is not present. Okay, 2 is not present. So basically page fault will be incremented. That is okay. But now I have gone into a condition where all the frames are full. So basically that case is handled by else. So I should not come to if. So here flag variable is saying, okay, if you are false, then check this. Otherwise, just go out. So flag has become true last time. So what I will do? Flag true equal false? No. So I'll not come inside if, I'll go to else. Okay, and this flag will not be made to false again. Okay, this else code is not using this flag variable. Okay, so this flag variable will remain always you can say true. So I will not come to this if again. Okay, so I will again come to else only. Okay, so here if you see inside else, the frame, print, update, page table, okay, these are the same lines here, right? But before these 3 lines, I'm updating the page table. So this line is basically helping to apply the FIFO algorithm. This is basically helping to replace or remove the page using the FIFO algorithm. Okay, so first apply the FIFO and then do the same thing that you were doing. Okay, and at last you update the current. Okay, so more or less this code is also same, just we have to add this line, right? So what we are doing for this two, first come here and update the page table. Okay, that is apply the FIFO and then update the page table. So basically in FIFO I know that now I have to update this 0th frame, right? Then 1, then 2. Okay, so basically here if you see what we are doing, what we are passing, we are basically passing the PT, that is a page table, then we are passing frame current. Okay, so we are actually passing frame current means the current has become 0, right? That's last time. So frame current is this 7, that is this should be replaced. Okay, -1 is like the frame number for this 7. See, we are removing this 7, so that means this 7 will be like going out of this frame. Okay, so for this 7 I have to update the frame number inside this page table. So what should be the like frame number for this 7 after it is removed? So any invalid page frame number, it can be like -1, so I'm sending -1. Okay, and 0 is like you set the valid bit as 0 for this you can say this 7. That's why I'm passing this stated bits as 0. So what will happen from here? -1 and 0 are passed. So if you go up, okay, if you go not here but here, okay, so 1 minute. Okay, so if you go up in the update page table, here you can see everything will be coming. Okay, every 4 entries, and then status bit will be going inside valid, that is 0 will be going inside this here. Okay, for the 7th, okay, page number is 7, for the 7 this will become 0 and the frame number will become -1 simply. Although we need not to like update this, okay, valid bit will take care of everything, but let's do -1. Okay, so this way I have updated everything for the removed page. Okay, and after that what I will do, I will put this my page, that is this 2, okay, this 2 in here. Okay, that is frame array current will now contain my reference string. Okay, then I print and then I updated the page table. Now can you tell me in the update page table what should be passed? Page table, and then the reference string will be like 2. Okay, I want to update the entry for 2, so what should be the frame number for this 2? 0. Okay, that means current, right? And what should be the valid and invalid bit for this 2? It should be 1, that is it is valid. So for 2 it should be 1, so I'm passing 1 here. You can see here, so 1 is passed. Okay, so basically update page table will do what? For 2 it will be 1 and the frame number will be 0. Okay, so this is removed and this is coming. Okay, so this way it is updated. Now next time what I want to do, I want to update current to next. Okay, so here I'm not doing current equal to current plus 1 only, I'm just doing current equal to current plus 1 mod number of frame. I'm doing this much of calculation. Why? Because this code will do what? For 0, it will be like 0 plus 1. Mod number of frame are 3. So 1 mod 3 will be, remainder will be 1. That is okay. When I want to update this from 1 to 2, it will also work. 1 plus 1, 2, 2 mod 3, remainder will be 2. After it become 2, next time I want to update it to 0, right? So when it will be 2, then I want to update next time it to 0. So 2 plus 1, 2 plus 1, mod number of frame are 3. So 2 plus 1 is 3, 3 mod 3, 3 mod 3, it will become 0. So if it is 2, it will become 0. So this current is basically helping me in the circular movement, and this is a very good trick in the data structuring algorithm. Okay, whenever you want to move in the circular fashion, do this mod type of thing. Okay, but do not do current equal to current plus 1. Okay, you can do that thing, but you have to apply some if and else. Okay, so this is the good way. Okay, so basically the same thing will happen for like in the for loop. Again, you will go for this next 0 thing. Okay, and for 0 thing you will see that there will be no page fault. Okay, so this if will return true actually. Sorry, it will return false, that actually page is present, so it will not come inside. Okay, you will leave everything if and else. Okay, you can do by yourself. And then again, if you go for 3, again it will generate page fault. Page fault will be incremented, and then you will see that current, okay, although current will become actually what? Current will become 1. Okay, when you will come to 3, okay, the last time the current was 1. 1 is less than 3, but before that there is a condition whether flag is false or true, because flag is always true. So true equal to false, no. So that's why you will not come inside, although current is less than number of frame. Okay, that's why I said this if will not run now. Okay, this will not run. So for 3, again you will come this to this else, and you will do this again, same thing. For 3 you have to replace the page, you will replace this. Okay, you will replace this, and what you will do, you will replace, and then for 0 you have to update the page table that you are removing. Okay, you will do this thing and setting of the valid bit, and then you will say okay, 3 will come here, and then update the page table for this 3. Okay, and then current plus 1 mod this, that means current will become 2. Okay, so this way this whole code will run for all the rest of the reference strings. Okay, reference page numbers. Okay, and total you will get 9 number of page fault after this for loop gets over. Okay, so number of page fault will be 9, right? So yeah, this was all about the total number of page faults generated. Okay, so total number of page faults was 9, and how you can find the page fault ratio that I told you. Total number of page fault is 9. 9 upon this n is actually what? 9 upon, these are total 10 reference strings. So 9 upon 10, it will be 0.9, or you can say 90%. Okay, because in C, integer by integer is like integer only, so you will get only 0. Okay, so you have to make any one of the thing as a float. So I'm using typecasting. The same thing for hit ratio, n minus page fault, it will give you number of hits divided by n. Okay, it will give me the page hit ratio. Okay, so I have made float to this. Okay, for the floating answers. Okay, so I hope you have understood the code. So basically, before ending this video, let me ask you, what is the time complexity of our implementation for the FIFO algorithm that we have just seen? Okay, so basically we are running this for loop n times. Okay, n times. Okay, and for each of the page, what we are doing, we are searching. Okay, we are searching that page, but we are not searching inside this frame array linearly. Okay, we are just using this page table. Okay, so we have made the function is page present, that was checking this page table valid bit or the invalid bit, whether that is 0 or 1. Okay, so that will take just a constant time, because we are just directly accessing this page table. Okay, for that particular if page. Okay, so that is page present will have the time complexity as O of 1. Okay, and after that we are checking, okay, if that is not present, whether frame array has vacant frame or not. So here we have just used a simple constant time, you can say operation. Current is number of frame, current is less than number of frames. If it is okay, then we are having the vacant frame. Okay, so again this has no function call or okay, and it is like a simple O of 1 time complexity. Okay, then we are putting the ith page into the vacant frame. Okay, so what we are doing, we are simply saying, okay, go to 0th page, 0th frame, first frame, second frame, or any of the 0th 1 2 frame. Okay, just directly go to the current frame actually. Okay, so again it is directly accessing. Okay, and update the page table is also again a constant time. Go to that particular page. Okay, go to, let's say, 7th page and update this and this. Okay, again it is a O of 1 time. Okay, and let's say if we come to else, again here what we were doing, update the page table. Okay, then again we were doing these things again, right? So these were O of 1, this was O of 1, right? Okay, so if you see, for each of the n times we are doing all the operation, but all the operation are like O of 1 times. Okay, so basically this will be of O of 1, right? This will also be O of 1. Okay, and either we will do if, or we will do else. Okay, so this basically will be of like O of 1 only. Okay, so this if and else is okay, and again this is of O of 1. So basically if you see, n times we are coming, okay, and each time we are doing the operation of O of 1 time. So basically the complexity will be of n. Okay, this is equal to n only. Okay, order of n. Okay, and what will be the space complexity? So what we are doing, we are taking the space for this, you can say, frame array, and we are doing the or we are taking the space for this page table. So if we take the space for the frame, okay, so it will be like O of number of frames. Okay, whatever number of frames we are like taking, let's say 10, 12, or let's say here we are taking 3. So of number of frames plus we are taking the space for this page table. So you can, oh, whatever size of page table is there, that will be the time of complexity. Okay, so yeah, this will be like space and time complexity for our FIFO page replacement algorithm. Hope you have understood the video. Hope you have understood the page replacement algorithm for the FIFO. And if you have not understood any of the thing, please rewind the video. And again, if you're not able to understand, please write down into the comment box. I will surely answer and I will try to make you understand. Okay, so please like and share this video, subscribe the channel, and press the bell icon for further notification. See you in the next video with the next algorithm, that is LRU. I will tell you the C program for that code. Okay, and before that, please watch the video of the LRU. Okay, so most of the code of the LRU will be similar to the FIFO. Okay, only slight change will be there in the LRU implementation. So see you in the next video. Till then, goodbye.